Hello, I'm Andrii Matsevytyi, a second-year student here in Vilnius University. I'm very glad to have such an opportunity to present. It's my first paper. And basically today I want to tell about it. The topic is exploring convolutional architecture capabilities for image classification tasks with insufficient amount of data. So to begin with, nowadays convolutional neural networks are used almost everywhere, from facial recognition in your phones to malware detection and threat evaluation. Despite it looks different to other image classification approaches, CNN addresses the issues of insufficient quality or insufficient amount of photos in the dataset. In this report, I will analyze the most common methods for image classifications that involve usage of feed-forward convolutional network. Object of the study is small-size self-collected dataset. I collected on my own, and there are different classes where different classes represent features of different levels. Subject of the study is to explore the capabilities of network overall, of key architecture blocks and their combination. History of convolutional neural network is not that big. First one approach is considered to be LeNet 5. It was introduced in the 1990s, and on digit classification task, it approached human language. However, from then, all the similar-looking solutions couldn't really work on real-world scenarios, and the first approach to overcome it was AlexNet. These are two networks that I will be using as an inspiration when designing my own. Also, further approaches use similar architecture, but increased depth of the layers, which means that from one point we get higher accuracy, from another point we need data of bigger amount of higher quality. Yes, so I will start with a bit of theory. Basically, convolutional network consists of three types of layer: convolutional, Boolean, and dense. Convolutional layer is cornerstone layer in convolutional network, and its task is to extract different features. How it works? There is a kernel. It slides through the image. It applies different numerical transformation. Usually it is an elemental product, and it outlines some distinct feature as a result. There is very big, very diverse amount of kernels, and they are classified. You may see to the left an example of some kernels. Depending on the features they extract, they are classified. Also, there is some kernel mess. It's if you want to get some mid-level kernel, you should combine a few low-level kernels. And therefore, the more complex pattern you want to get, the higher amount of convolutions you should use. The only problem with convolutional layer is that when each kernel is applied, extreme big amount of image copy is introduced, and therefore it's both very computationally complex to calculate it, and also it starts capturing some noise, and it makes it very hard to train the functional, the classification neurons. Therefore, there was introduced Boolean layer that decreases the size of the image while preserving the necessary feature. Here you may see the most basic layer. It's most widely used nowadays. It's 2x2 max Boolean layer. Also, there is dense layer because on one hand we have Boolean and convolutional layers that extract and refine features. On another hand, we have dense layers that matches the extracted features to the class probabilities. So if you talk about dataset, I choose seven classes. There was 100 images for each classes. You may see examples of those classes to the left. And you also may see that, for example, pentagram, inverse pentagram, and anarchy contain mostly low-level features, while skull and horn gesture contain mid-level features, and punks and metallists have high-level features. Also, I applied different augmentation types to reduce model overfitting. And if you talk about the model itself, I used why convolutional model should be used for this approach. First of all, it's taken because it captures spatial relationship in data, and this should make the model more inert to different image transformations that occur when different amateurs capture the dataset. Also, convolutional network can work having a small amount of training data. Approach and hyperparameters were mostly influenced by these two architectures. And however, I couldn't use these architectures on their own because from one point, the Net5 was designed for simpler relationship. From another hand, AlexNet couldn't be used because dataset is too small and it will just underfit. Also, for hidden layer, I use ReLU activation function, and for output layer, I use softmax activation function. My architecture plan was to start with different amount of pairs of convolutional and max pooling layers to see how they work, then to perform additional convolution layers in the best performing result, and then add additional dense layers. Amount of convolution started from 32 kernels and increased by 2 each layer, so that I will be able to capture all combinations of convolutional layers. For evaluation, I used top 1 accuracy over 200 of epochs. I didn't use early stopping because the task is to see how model performs and how it performs in a long time perspective. Also, I use confusion matrices to better understand how models performs for different classes and how, therefore, which features has its problems, so it doesn't have any problems to extract. Yeah, so if you talk about the results, firstly, I tested different pairs of convolutional network, of convolutional and pooling layers. As you may see, one pair performed very poorly, while other pairs performed always at the same place. I think partially it is because I didn't have a big amount of data. Partially it is because there was too much pooling layers. If you look on third one, you may see that it can't really capture. It has problems while capturing high-level features, and 4 pairs has problem in distinguishing classes with similar with features of similar level, similar features that are used for different classes. So I took 2 pairs model and I applied additional convolution. It could be applied in different places, and as you can be seen, the one applied to the front performed the best. So after that, I tested having different amount of dense layers. What I can say about this one is that adding 1 or 2 layers didn't influence much the model performance, but it really differs from the initial approach, which means that model was able to capture these relationships between simple features that look similar but belong to different classes. For example, pentagram and inverse pentagram, they look almost the same, and they have same features, but the combinations of the features are different. Yeah, and if to talk about conclusion, so in this research I aimed to study the convolutional neural network from scratch, and my research can be used either in other studies related to data sets of small amounts. There is big amount of there are fields where it can be applied. For example, it is use subcultures, it is malware, it is space exploration, it is rare species classification. Convolutional neural network performed great despite the data set was pure and it was small. Also, it was really able to ignore image translations, scaling, deformation. I found out that adding arbitrary amount of pooling and dense layers helped to prevent overfitting in long perspective, but while increasing only one part of the model, it led back to model overfitting. The best performing approach achieved more than 91% of accuracy. To the right, you may see how different approaches worked. And if you talk about further research to optimize the result, big research should be done, of course, and also high attention should be paid to recurrent neural network and image segmentation tests. Thank you very much.
Thank you very much.